section 23.12, the Robinson annulation. In general terms, the Robinson annulation is the reaction of a stabilized enolate and this is any of our stabilized enolates will work with a Michael acceptor. Except more than just a Michael addition occurs. A Michael addition occurs and it's followed by transenolization to a different aldol enolate and then an aldol reaction with elimination. So the product of this reaction okay, we're 1, 2, 3, 4, or 4, 3, 2, 1, and the carbonyl system let's go A, B, C, A, B, C are right there. So you can see with the Robinson reaction, you can very quickly build up complex structures that again were major synthetic targets in organic chemistry not very long ago. This also serves as a general example or a specific example of this. So we want typically these beta keto carbonyls, but it's just this general stabilized enolates that are very useful in this reaction. Now, the mechanism. Let's look at this mechanism, and I put this specific one on purpose to choose it for the mechanism. So, we start with our beta diketo compound. We have our base. Typically this is going to be done in an alcoholic solvent. We know that this is a strongly favored equilibrium. So we form our stabilized enolate. They can then undergo a Michael addition to, in this case, methyl vinyl ketone. So starting at the highest electron density, the anion swings down, nucleophilic attack on the electrophile, and we have the Michael type addition. Now we know that this compound is now much more basic than the stabilized enolate, so it gets protonated. I turn turn that upside down. I'm going to turn it back over because I want you to begin to be able to think clearly about these kinds of compounds without so we protonate it, and I've drawn this to try and emphasize or illustrate for you 1, 2, 3, 4, 5, 6 now. Okay, so of course there's a hydrogen here. So this is our trans-enolization. This enolate's protonated, it makes an ethoxide. So that ethoxide is catalytic. We deprotonate. You make a new enolate. All right, so we now have 6. A new enolate. We can now do the aldol addition to that carbonyl. So we now have made the fused 6,6 ring system. We need to protonate this, and we have our ethanol from before. We can protonate it. Now remember, the elimination reaction in this is an E1CB. It's the unimolecular elimination from the conjugate base. So we have to deprotonate here first. Now we just made an ethoxide, anion. We will make the enolate. And just as we saw with the aldol now, the elimination is this unimolecular process from the conjugate base, reform the double bond, carbon-oxygen, carbonyl double bond, kick out the hydroxide. Now again, hydroxide's not typically a good leaving group, but under strongly basic conditions, that then produces, and this is our irreversible step, so we now have this highly functionalized 6,6 ring fused, 6,6 fused ring system that we're ready to do lots of new and interesting chemistry. So that's the Robinson annulation. If you only study one mechanism in 23, study this one because it's got everything in there.